Hi there, and welcome to Topic 7. Today we are going to be looking at combining like terms to solve equations. Now, this lesson in particular should be pretty familiar to you in that we've already done work with combining like terms to solve equations, and we did that back in previous topics, and we've been working on it ever since. So there should not be a lot of new information in this lesson in particular. But we use this as a springboard to get us into the habit of making sure that we are correctly combining like terms in order to solve equations, which we are going to be doing in much more detail in future lessons. So let's take a look at the Explore It. It says a superintendent orders new laptops shown below for 2 schools in her district. She receives a bill for $7,500. A, draw a representation to show the relationship between the number of laptops and the total cost. Well, what I see here is in the first stack we have 3 laptops, so we'll call that L. In the second stack we have 4 laptops, we'll call that 4L. And in the last stack we have 3L again, where L stands for the cost of each laptop. And the total cost of all the laptops, again, was $7,500. Now we're going to use this equation, okay, right here, and we're going to solve that to find out and determine the cost of one laptop. Well, what you should see here is that you have terms that are all the same, because essentially you're just counting up how many laptops do you have all together. In this case, you have 10 laptops, and that has to equal a total of $7,500. We assume that all the laptops are the same, and we assume that each one of them has the same cost. So we would then divide both sides of that equation by 10 in order to understand that each laptop must have been $750. Now let's take a look at example 1. In this example, we're going to combine like terms to solve addition equations. You'll notice in this lesson, and this example in particular as well, that you're going to be dealing with fractions, and these fractions are not fractions that you can turn into decimals. So when that is the case, because they would be repeating decimals, you have to leave them in fraction form, use common denominators when you're adding or subtracting, and understand how to get rid of a fraction coefficient in front of the variable by using that multiplication and reciprocal. We'll talk about that here in just a minute. Gianna has 36 yards of fabric to make sets of matching placemats and napkins. How many matching sets can she make? One of the things that I would like for you to consider in this example in particular is the look for relationships box. It says, why can you use the same variable to represent the number of placemats and to represent the number of napkins? Well, if you go back up to the original problem, it tells us that we are going to make sets. Well, a set contains 1 napkin and 1 placemat. And because its set contains 1 of each, okay, 1 napkin and 1 placemat, then we can use a variable that is the same for both of them. We're talking here about the amount of fabric that we need, and we know that we're going to need that fabric for an equal number of sets. So the X here in each of these tells me we're going to make X placemats and X napkins. But since we are using a set, that means that every placemat will have a napkin to go with it. So now we're going to use the numbers from the problem. Okay, we have 1 1/3 yards of fabric needed for the placemat, and we have 1/6 of a yard needed for the napkin. So we're going to take 1 1/3 yards X plus 1/6 X to represent the total amount of fabric that we need to make a set that includes a napkin and a placemat. So we're combining those 2 fractional pieces here, get a common denominator, and we're going to combine them to find out the total amount of fabric we need for one set. Okay, Now, in order to solve this equation, because you have 9/6, that fraction 9/6 in front of the x, you have to multiply by that reciprocal, okay, 6/9, okay, that reciprocal relationship. And then recall that when you multiply over here by that 6/9 as well, you're going to be multiplying 6 times the 36 and then divide that by 9. Okay, and that's where they get x is 24. So in other words, Gianna has enough fabric to make 24 matching sets of placemats and napkins. Now I'd like for you to take a look at the try it. Set up the problem and see if you can solve it. And when you're done, come back and check your work to see if you did it correctly. Okay, go ahead and take a look at the work that goes along with the try it and see if you did that one correctly. Again, remember, because the necklace and bracelet are being sold as a set, then we can use the same variable S to represent the set. Now I'd like for you to take a look at the convince me. Suppose the equation looks like this. Can you combine the S terms and the 4 6/10? In other words, when you simplify and you combined the like terms in the try it, you got $17.98 per set of necklace and bracelet. But can you combine that with the 4 6/10? So is it okay for me to combine those? And the answer is no. Okay, these are not like terms. Why not? They're not like terms because one of them has a variable and the other one does not. Okay, one is a variable term. Okay, so you have a variable term right here. And you cannot combine variables and constant terms with each other. In example 2, you should recognize this situation as something that we just got done discussing in the previous topic. Celine bought a computer screen on sale for 35% off the original price. What was the price of the computer screen before the sale? So they want us to first draw a bar diagram to represent the situation. And P is going to be the representation that we use for the price of the screen before the sale. That's the original price. Okay? All right. The 35% sale means we're going to take 35% in decimal form times the original price. Okay? And then the sale price is the $130. So when we use that bar diagram, what we're essentially doing is saying we're going to take the original price P, we're going to take away from that the sale price, okay, so that's our 3,500ths times P, and then that equals the sale cost, which is $130. Now you should recall from the previous lesson that anytime you have P or any variable, there's a 1 in front of that P. Okay, and because there's a 1 in front of that P, when you combine your like terms, you're essentially saying, what is the value of 1P, take away 3,500ths P, and that equals 6,500ths. Now, when we discussed this in our previous topic, remember we discussed that when you take away the sale amount in a percentage form, what's left is the balance that you're actually paying for. So what this problem is saying is, if I get 35% off the price of an item, then that means I'm actually paying for 65% of the original cost. Now, in order to solve that, you're going to go ahead and do what you see here in the work, which is divide both sides by 6,500ths. And when you do that, you find that P is equal to 200. So before the sale, the price of that computer screen was $200. Now I'd like for you to do the try it and come back and check your equation and your answer and work that goes with that. Okay, go ahead and check your work and your answer for the try it. You can see that I set up the equation first and I combined my like terms. And then what I did is I took my equation with the like terms combined, and I went ahead and showed my work over here on the right side of the page to solve. Now, what you'll notice is that when you get to using your calculator, because this is money, you have to round to the nearest penny. So that means 2 decimal places after the decimal point. All right, now I'd like for you to take a little bit of time. I just want you to review example 3. Again, nothing new here, no new information. You're combining like terms again. Just because you have a negative number in front of a variable or a negative coefficient does not mean that you treat it any different. You're still going to do the same thing that we did with rational numbers back in topics 1 and 2. So I want you to go ahead with the try it questions here and work those out and come back and check your answers. Now I'd like for you to take a look at the key concept and the do you understand questions. Make sure to take notes on questions 1, 2, and 3 before you go on to the do you know how questions and try those. I would like for you on the do you know how questions to try both or all 3 of them, 4, 5, and 6. When you've taken your notes and you've tried 4, 5, and 6, come back and check your answers and we'll see how you're doing before we move on. All right, here you can see the work that I did to answer question 4. Notice that there's quite a bit of extra stuff here that you have to do, okay? You not only have to take your 2 like terms and get a common denominator with them, but then after you add them, you'll notice here that you have to do some regrouping, okay? 7/6 is an improper fraction, so you need to regroup that and make that 3 1/6. And then you have to change that 3 1/6 into its improper fraction form, which would be 19/6. And you need that as an improper fraction before you can multiply by its reciprocal in order to get the final answer, which is Henry can make 30 cakes. Now take a look at question 5 and the equation and solution that go with that one. Notice that I divided both sides by that 70 hundredths or 7/10. And P is 500,000 people. That was the population of the city 10 years ago. All right, and take a look at your last one here on this page, number 6. Notice that you combine your like terms there. You see that circled in blue. And then you're going to divide both sides of that equation by that negative 25 6/10 to get z equals 7. Okay, on the practice and problem solving, I would like for you to pause the video, and I want you to specifically take a look at the questions 7, 8, 9, 10, 11, and 12 to start with. I especially feel like we need to do some more practice with the fractions. Please do not change those fractions into decimals. Work with them as they are listed as fractions because you're going to need that practice for your Math Excel. Okay, come back and check your answers and we'll do those one at a time. Then we'll be ready to move on to some word problems. All right, now it's time to take a look at number 7. When you combine those fractions, and you can see I did that off to the left, got the common denominator and combine them, you get 11/20 x equals 11, which means you need to flip that fraction, use its reciprocal, so 20/11 is what you multiply both sides by, and when you do that, you end up with x equals 20. Okay, number 8, it's pretty straightforward there with the decimals. Don't forget that the negative 65 hundredths is negative, and the 45 hundredths is positive. Okay, and you should have gotten x equals a negative 27. All right, and on number 9, you should have gotten x equals 135. Check your work on that as well and see me if you have questions. Check number 10 and the work that goes with that, and you should have gotten x equals a negative 23. Now check number 11. You should have gotten x equals 3. And go ahead and check number 12. You should have gotten x equals 70. Now what I'd like for you to do, once you've checked your answers there, is to go on and try number 13 and number 14, okay? And we'll stop there and check those two first before we go on any further. All right, for number 13, it tells us that a contractor buys 8 2/10 square feet of sheet metal, and she used 2 1/10 square feet so far, and has $183 worth of sheet metal remaining. So we need to first decide what is the equation we're trying to solve before we try to solve it, which is to find out how much does sheet metal cost per square foot, okay? In this case, we know that we have 8 2/10 square feet of sheet metal, and the cost is M per square foot, minus, we're going to take what she used, which is the 2 1/10 square feet of sheet metal, and when we subtract that, we're going to find out how much sheet metal does she have left, and that's 6 1/10 square feet. And that sheet metal is worth $183. So this is the equation that we're trying to solve. And when we solve that equation, what we end up with is $30 is the cost of 1 square foot of sheet metal. So that sheet metal costs $30 per square foot. For number 14, if you add your two fractions together and then you use your reciprocal fraction, you should get that the number of pounds of raisins he had at the beginning of the week was 32. Now I'd like for you to try number 15 before we move on to the back page. And for number 15, the maximum depth of that submarine would be 780 feet below sea level. On the back, I want you to go ahead and try 16, 17, and 18, and then come back and check your answers. All right, go ahead and check your work for 16, 17, and 18. And when you're done with that, you are ready to move on to your assignment. Please make sure that you have copied down the work that goes with each of those problems, not just copying the correct answers.